This is lesson 9.10, surface area of pyramids and cones. So in the last unit, we found the surface area of prisms and cylinders, and today we will look at these other shapes. So the formula for surface area of a regular pyramid or a right cone can be found by examining its net. So we're going to look at that real quick first, and then just jump right into the formulas. So you can see here on the right side, we've got an oblique pentagonal pyramid, oblique meaning it's not right. So from the apex here to the center of the base, it is not hitting at 90 degrees, it's leaning. That would be oblique. Pentagonal just meaning that the base is a pentagon. It does have a regular base, so all the sides are the same. And you can see the net right here. So if we cut down each one of these edges and then folded them out flat, this is what's called the net. And you can see because it's oblique and it's leaning to the side, these triangles are all different sizes. So because of that, there's not a formula that's going to go ahead and just find the lateral area of all of these sides here because they're all different. And depending on how many degrees it's leaning, it's changing all of those sides. But you could still find the surface area of this. You would find the area of the base, and then you'd have to individually find the area of each one of these triangles, put them together for the lateral area. We're not going to look at one specifically like this. You're very rarely going to see that. We're going to look at pyramids and cones that are regular and also right. And they do have a nice formula that you can basically summarize all the sides because they're going to be equal to each other. But just in general, the surface area for any pyramid or cone, whether it's regular or not, is the lateral area, which would be all of these triangles, all of the sides that go up to the apex from the base, plus the area of the base. So it looks very similar to our prisms and cylinders, except instead of two bases, there's just one. So you find the area of all of these lateral faces, and then you add it to the area of the base, and that's the total surface area. Now remember what surface area actually represents is the material on the outside. We're not filling it in. It's a hollow shape. So if this was a cardboard box in this shape for whatever reason, we would be calculating the amount of cardboard it takes or the amount of material it takes to create the outside of that hollow box. So it's always lateral area plus the area of the bases. But we're specifically going to look at regular pyramids, and cones will fall under this as well, right cones. So we are still going to be using this when we do surface area, lateral area plus the area of the base. So even on a shape like this, we know how to find the area of the base. It's the lateral faces that are a little bit tricky. Now they're triangles, we could figure those out. But just like we saw with our prisms and cylinders, there is a lateral area formula that will work when we have a nice right regular pyramid. All right, so it says there's no simple formula for the lateral area of every pyramid. However, when the pyramid is regular, there is a simple formula for lateral area, and it's right here. So it's 1/2 times the slant height. So when you see this little L, we need to know that that's the slant height. Now remember, slant height is different than the height of the shape. So the height of the three-dimensional shape goes from the apex and drops down to, if it's a right regular shape like this, it's going to drop straight down right into the middle of the base. The slant height is running down the side of this lateral edge, or not on the lateral edge, but it's the height of the lateral face. Okay, and it's going to come down here. So it's basically the height of any one of these triangles that goes around the outside. And remember, if this is a regular pyramid, all of these triangles are going to be equal to each other because all of these sides of, in this case, the hexagon at the bottom are the same. So you're going to have 6 equal triangles. The slant height is the height of one of those triangles. It's not the height of the entire three-dimensional shape. And then we know P then is perimeter. That could be circumference, right? If we're dealing with a cone, the perimeter of a cone is the circumference. Those two words are synonymous here. So I would add up all the sides of the base here for perimeter, times it by the slant height, and take half. Think about where that comes from. The area of a single triangle is 1/2 base times height. And that's basically what we've got here. Here's the 1/2. Okay, the slant height is the height of that triangle. And then P represents the base, but not just one base, however many bases there are. Okay, so we're basically just finding the area of the triangle and then timesing it by how many sides there are, because all of those triangles are the same. So that's how this gets wrapped up. All right, so this will drop in for lateral area right here. If you're going to find surface area, you would change lateral area to 1/2 slant height perimeter, and then you add it to the area of the base. Area of the base will change depending on what it is. If it's a circle, it's pi r squared. If it's one of these regular shapes, it's 1/2 AP. If it's a triangle, it's 1/2 base times height. If it's a rectangle, it's base times height. Right? It could be any number of different shapes for the base. So let's look at two quick examples here on the back. We're going to start with the lateral area here. So we'll find the lateral area and then we'll find the surface area. So lateral area again is just 1/2 slant height times perimeter. Again, it's basically the triangle formula. You're finding the area of one of the sides and then timesing it by how many sides there are. That's what this accomplishes. And then we're going to find the total surface area, where we will take this answer, the lateral area, and then add it to the area of the base. And now we have the total surface of the entire shape, where up here we just have the triangles that are going from the base to the apex. We're not including the bottom. So this is pretty simple to use, especially if you're given all the information that you need. In this case, you can see this is the slant height. It goes from the apex and then it goes down to this bottom edge right here. It's not going to the center of the shape. That would just be the regular height. We would have to use Pythagorean theorem or something like that to go ahead and find the slant height if it wasn't given to us. That will happen sometimes. But in this case, they gave you the slant height. It's 12.2. And then perimeter is perimeter of the base. So around the base here. Now we're looking at regular pyramids. So all of these sides are always going to all be the same. That is labeled here for you. We have 7, we have 7, and we have 7. Those are the 3 edges of the base. This 6.1 is the height of the triangle that is the base. So we're not using that right now. All right, so all 3 sides are 7, 7, 7. So perimeter is going to be 7 times 3, which is 21, if you want to note where this number is going to come from. So perimeter is 21. That's of the base. And then you're simply just going to go ahead and multiply that all together. Multiply, take half, or call this 0.5, whatever it is that works for you. That comes out to 128.1. And let's put some units on it. Remember, area is always squared because technically this represented meters, this represented meters, and when you multiply meters times meters, you get meters squared. So the lateral area is 128.1. So that's the area of all of these lateral faces. If we want the total surface area, we're going to take this number plus the area of the base. So let's go ahead and drop this number right in for lateral area, 128.1. And we're going to add that to the area of the base. In this case, the base is a triangle. So we're going to go ahead and drop in our triangle formula, 1/2 base times height. Let's go ahead and plug in those numbers. So 1/2. So finding your base and your height of just the triangle. Now we're not looking at the 3-dimensional shape. We're just looking at the base. So this triangle right here, look for where things hit at 90 degrees always for your base and your height. So we talked about that 6.1 already. That's going to be the height. So it's hitting this base. So the base of this triangle is 7. And the height is 6.1. So when we go ahead and multiply that out, 7 times 6.1, take half, that comes out to 21.35. And we still have the lateral area sitting there. So the area of all of the lateral faces is 128.1. The area of the base is 21.35. So the total area, the total amount of material that it's needed to make this shape on the outside, when you add that up, comes to 149.45 meters squared. All right, let's drop down and try a cone, and then you are off and running. So example number 2, let's find the lateral area first of the cone, and then we will find the surface area. So we're going to use the same formula. We're just going to have to think about how we find certain things in a circle. Lateral area, though, is still half of the slant height times perimeter. All right, in this case, slant height was given to us. Slant height goes down the side of the cone. If they had given you this height instead, you couldn't plug that number in. You'd have to work with your 30, 60, 90 or Pythagorean theorem to find the slant height. So be careful. Don't take the height of the three-dimensional shape and plug it in for slant height. All right, but we're given the slant height. It's 10. And then we have to plug in for the perimeter of the base. Now the base is a circle. Perimeter of a circle equals circumference, which is pi times diameter. Cherry pie is delicious. So we need to find the diameter of this circle. That gives us circumference, which is the same as perimeter. So if I do take a look at this triangle, because it's a 30, 60, 90, if I have a 30 and a 90, I know this is 60, and I'm given one side, I can find all the missing sides. So right now I've got the hypotenuse across from 90. That's my 2x. Across from 30 is my x. That's all I'm going to need. That's going to give me the radius, and then I can find the diameter. If I needed this height right here, that would of course be my x radical 3. But in this case, because we're finding surface area, that's not one of the units that we're going to need. So since this is 10 and it's in the 2x spot, this is going to be half the size because it's x. So that's 5. So if I do the radius in the other direction, it's also going to be 5. So my diameter then is 10 all the way across. All right, so let's plug in one at a time here. I'm going to go ahead and put pi times diameter in, so you can see where we got this from. Perimeter is the same as circumference, pi times diameter. Then we'll go ahead and we'll actually plug in. The diameter is 10, so the circumference is 10 pi. 10 goes in for diameter. And then we're going to go ahead and multiply all the way across here. 10 times 10 is 100. Take half, and that's 50 pi. We're going to go ahead and leave pi in it instead of rounding the decimal like we've been doing. All right, so don't forget to put pi. Don't just put 50 because this is actually 50 times 3.14. So it's actually over 150 is the number. So you can't just leave off the pi and call it 50. And then, of course, we're going to go ahead and put in our units here. This would be inches squared. Now that we've got lateral area, we'll go and get the surface area. We're going to use that. So surface area is the lateral area, so we'll drop that right in, plus the area of the base. So this area, again, is kind of the whole curved side of the cone, how much material is there, and then we're going to add the material that it would take to close off that side of the cone. That would be the area of the base. So let's go ahead and drop in the lateral area. We figured it out already. It was 50 pi. Now the area of the base, be careful, that's different than circumference. Circumference was the perimeter. We want the area. The area of a circle is pi r squared. Okay, so that's what we're dropping in here for the area of the base. Apple pies are 2. Cherry pie is delicious. Apple pies are 2. All right, we've got all the information we need. Let's just drop it in. We just need to put the radius in. So pi times radius squared, the radius is 5. 5 squared. Now you can shorten this up, but for your notes, I'm going to go ahead and just go line by line, plugging things in. 5 squared is 25 pi. And so my total surface area here is the lateral area of 50 pi plus the area of the base, which is 25 pi. So my total surface area, 75 pi square inches.